Hello and welcome to the Logic of It All. In this video, we are going to still talk about set theory, but in particular, we are going to focus on the concepts of a subset, equality of sets, and power sets. So what does it mean for a set A to be a subset of another set B? So we say A is a subset of B if every element of A is also an element of B. So everything that belongs to A also belongs to B. And we use this notation here to represent this property. A is a subset of B. Now here's an example. The set 1 and 4 is a subset of the set 2, 4, 1, 12. Now what makes this statement true? What we need to verify is that every element that belongs to the set on the left also belongs to the set on the right. So if we start from the first element, 1, does 1 belong to the second set? Yes, it does. How about 4? Yes, it does. So we verified that every element that belongs to the set on the left also belongs to the set on the right, and that's what makes this statement true. Now here's another example. The set containing 2 and 5 is a subset of this other set that is defined using set comprehension. The set of all x's such that x is a positive integer less than 10. Now, if you want to, you can write this set down by listing all these elements. So positive integers less than 10, that is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and now we can verify. The first element of the first set is 2. Does 2 belong to the second set? Yes, it does. The second element is 5. Does 5 belong to the second set? Yes, it does. And that's what all we need to do. So the statement is true. Here's another example. The set 2 and 5 is a subset of the set 2 and 5. Again, you do the same thing. 2 belongs to the set on the left. Does it also belong to the set on the right? Yes, it does. How about 5? Yes, also. So this statement is also true. Now, this is a special case where the two sets are exactly the same. Now, if you think about it for a moment, you realize that this is not something specific to this set. Any set that you consider will be a subset of itself. And we will see this in the next slide when we talk about the properties of subsets. So a better way to think about subset, given that a set can be a subset of itself, is whenever you see this in your head, think of subset or equal, because it is allowed for the two sets to be equal, even though they don't have to be, because you see in the first example, they are not equal. Now, what if a set is not a subset of another set and we want to write that mathematically? So in this case, we say A, and then we use the subset notation, but we put a line through it. So this reads as A is not a subset of B. Okay? To clarify, let's take a look at an example. A is the set 2, 1, 5, and B is the set 1, 4, 5, 7, 8. And we claim that A is not a subset of B. Now, why is that? Because A has an element that does not belong to B, namely 2 here. Because remember, for A to be a subset of B, every element of A must be an element of B as well, but 2 is an element of A which is not in B, and that's why A is not a subset of B. Now, one important property of subsets is that the empty set is a subset of any set. Okay, so no matter what A is, the empty set is a subset of A. And then the other one, as we saw in the previous slide, is that, again, no matter what set you consider, for any set A is a subset of itself. Now, one common mistake that people make when they first encounter set theory is they confuse subset with the element relationship. Okay, so here's an example to clarify that. So if we consider the set 14, 5, 2, and 9, it is correct to say 2 is an element of that because 2 is listed as one of the elements of this set. But it would be incorrect to say 2 is a subset of this because 2 is not a set. Remember, subset is a relationship between two sets, and 2 is not a set. So we should say 2 is not a subset of 14, 5, 2, and 9 because 2 is not a set to begin with. On the other hand, if we put 2 in brackets, then we can say that yes, now 2 is the set 2 is a subset of the set 14, 5, 2, and 9 because everything that belongs to the set on the left, which is just 2, also belongs to the set on the right side. So the set 2 is a subset of this set. But now it's incorrect to say the set 2 is an element of this set because 2 with brackets is not listed here. We have 2 by itself, but not 2 with brackets. So the set 2 is not an element of 14, 5, 2, and 9. Now, natural next step would be, okay, so this is when we define the concept of a subset, so a subcollection. Now, when do we say two sets are equal? We say two sets are equal if they contain exactly the same elements. So everything that belongs to A also belongs to B, and everything that belongs to B also belongs to A. In that case, we say A and B are equal. And that's basically the reason behind why the order of the elements in a set does not matter, or why repetition is not important. Repetition of elements is not important in a set. Another way of thinking about equality of sets is we say two sets are equal if each one of them is a subset of the other. So A is a subset of B and B is a subset of A, which means everything that is in A is also in B and everything that is in B is also in A. Now, remember that we said every set is a subset of itself. And we said that think of that subset relation as subset or equal. Now, there is another notion that excludes equality, and that's called a proper subset. So A is a proper subset of B if it is a subset of B but it's not equal to B. In other words, when B has all the elements of A, but it has one or more elements that don't belong to A. So we say A is a proper subset of B. Now, in different textbooks, there are different notations for this. Some use this. You see that the equality symbol is removed now. So this is for proper subset. Or some use this notation here where they put a line through the equality. So it means that A is a subset of B, but it's not equal to B. In other words, A is a proper subset of B. Now again, to clarify this, we look at an example. So consider these three sets, A, B, and C. The first statement that we want to verify whether it's correct or not is that A is a subset of B. So if you check, does every element of A also belong to B? No, because 1 is an element of A that doesn't belong to B. So this is false. The second statement, B is a subset of A. Is that correct? So everything that belongs to B also belongs to A. 5 and 10, they both belong to A, so this is a true statement. Now, the next statement says B is a proper subset of A. So everything that belongs to B also belongs to A. We've already verified that, that's true. And B is not equal to A, that's also true, because A contains 1, which B doesn't. So this is a statement that says B is a proper subset of A is a true statement. And finally, C is a proper subset of A. Now, if you look at the definition of C and A, you see that they are the same sets because the order is not important. Both of them contain 1, 5, and 10. And because of that, C cannot be a proper subset of A because C is equal to A. C is a subset of A, but not a proper one. So this is false. And the final concept we are introducing in this video is the concept of a power set. So we have a set A. If we create a new set that its elements are all the subsets of A, then it's called the power set of A, and we denote that by P of A. Okay, so here's an example. Let's say A is the set containing 2 and 7. So what is the power set of A? So we start with listing all the subsets of A. So remember, empty is the subset of any set, so we start with empty. Then we go to subsets of A that have only one element. So 2 is a subset of A, and also 7 is a subset of A. And finally, we can have a subset of A that contains both 2 and 7. So basically A itself. Remember, every set is a subset of itself. So these are all the subsets of A. The empty set, the set containing 2, the set containing 7, and the set containing 2 and 7, all of A. Now, if I create a new set with these subsets as its elements, then it's called the power set of A. Here we go. Now, here's another example. Now, B has 3 elements. So if I want to list all its subsets, again, I start with the empty set, which is a subset of anything. Then subsets with only one element, so we can have either 2, 4, or 8. Subsets with 2 elements, so we can have either 2 and 4, 2 and 8, or 4 and 8. So we have 3 subsets with 2 elements. And finally, we can have all 3 of them. So 2, 4, 8 is the largest subset of B, which is B itself. And if I create a new set with these 8 subsets as its elements, that's the power set of B. Now, in the first example, A had 2 elements and it ended up with 4 subsets. In the second example, A had 3 elements and it ended up with 8 subsets. And you can see a general pattern here that where if A has n elements, it's going to have 2 to the n subsets, starting from the empty set, subsets with 1 element, 2 elements, all the way up to A itself. Overall, there will be 2 to the n subsets, which means that the power set is going to have 2 to the n elements.